We know that Arctic is of special concern because of the way it's warming. This is the temperature trend, surface temperature trend from 1994 to 2023. We talked about the Arctic amplification here because of ice albedo feedbacks, water vapor response to warming, and so on. And 2023-24 have been record-breaking warm years because of global warming plus El Nino and maybe plus a few other things. We have discussed elsewhere about how difficult it's been to explain the warm 2023. We don't know exactly why it got so warm. We are all surprised by it. So NOAA puts out the Arctic report card every year, and this one is for 2024. It's only December when I'm recording this, but the summer months are the critical months during which you want to monitor the sea ice, because whatever survives after the summer is going to likely grow back in the winter. So here are some nice pictures of the Arctic, and we'll look at just the headlines. A nice long report as usual. I'm going to be brief, and we'll look at some highlights and some results. So reading the headlines, 2024, the rapid pace and complexity of Arctic change demand new and strengthened Arctic adaptation and global reductions of fossil fuel pollution. We have discussed the Arctic issues elsewhere already about all the interest in the Arctic in actually losing its ice mass, because you will have then a direct passage from the North Atlantic into the North Pacific, and there is likely lots of fossil fuels at the bottom of the Arctic from the time when it was very warm, and during the dinosaurs, and a lot of oil, gas, and so on, maybe down there as well. The Arctic continues to warm at a faster rate than the global average. The 2024 Arctic report card highlights record-breaking and near record-breaking observations that demonstrate dramatic change, including Arctic tundra transformation from carbon sink to carbon source, declines of previously large inland caribou herd, and increasing winter precipitation. And it's not news, it's good news. Increasing winter precipitation would have been great if it was all snow. Observations also reveal regional differences that make local and regional experiences of environmental change highly variable for people, plants, and animals. We'll look at ocean temperatures, snow ice extent, sea ice extent, of course, phytoplankton response, and so on. Adaptation is increasingly necessary, and indigenous knowledge and community-led research programs are essential to understand and respond to rapid Arctic changes. Inuits who live there in the Arctic Circle are, of course, the original researchers, and there's some arguments made here about why they need support to continue their livelihoods and to provide key insights into what's going on there. Okay, so what's happening in the air? Arctic annual surface air temperature ranked second warmest since 1900. So that is record kept since 1900. Autumn 2023 and summer 2024 were especially warm across the Arctic, with temperatures ranking second and third warmest respectively. An early August 2024 heat wave set all-time record daily temperatures in several northern Alaska and Canada communities. Last 9 years are the 9 warmest on record in the Arctic. Last 9 years are the 9 warmest years in the Arctic. Summer 2024 across the Arctic was the wettest on record. Arctic precipitation has shown an increasing trend from 1950 through 2024, with the most pronounced increases occurring in winter. Such warming you expect to produce all sorts of atmospheric and oceanic responses, and increased precipitation is definitely one of them. But these ideas of heat waves reaching the Antarctic and Arctic are really shocking scientists and people, despite all the warming we are experiencing at lower latitudes. So we don't expect heat waves to reach polar circles, but nonetheless. In the ocean, what's happening? In September 2024, the extent of sea ice, which has a profound influence on the Arctic environment, was the 6th lowest in the 45-year satellite record. So that's the extent of sea ice. All 18 of the lowest September minimum ice extents have occurred in the last 18 years. That's one string of record. That is a shame. Arctic Ocean regions that are ice-free in August have been warming at a rate of half a degree Fahrenheit or 0.3 degree centigrade per decade since 1982. In most of the shallow seas that ring the Arctic Ocean, August mean sea surface temperatures were 3.6 to 7.2 degree Fahrenheit or 2 to 4 degrees C warmer than 1991 to 2020 averages, though the Chukchi Sea was 1.1 to 4 degrees C cooler than average. So we'll see the non-uniformity in a map in a minute. It's a U.S. report, so they keep, NOAA, so it keeps mentioning things in degree Fahrenheit as well. Long-term ocean primary productivity, plankton blooms continue to increase in all Arctic region. If you make it ice-free and warm, you're going to have phytoplankton blooms. Then you have to see what the feedback is from the phytoplankton on ocean warming as well. Except for the Pacific Arctic, throughout the observational record of 2003 to 2024, the blooms have increased in all Arctic regions. However, in 2024, lower than average values were dominant across much of the Arctic. The seal populations remain healthy in the Pacific Arctic, though the ringed seal diet is shifting from Arctic cold. Sorry about that. Ice seal populations remain healthy in the Pacific Arctic, though the ringed seal diet is shifting from Arctic cod to saffron cod with warming waters. So we'll see what these cute seals are and what species exist there in terms of these names that we just read. On land, what's happening? When including the impact of increased wildfire activity, the Arctic tundra region has shifted from storing carbon in the soil to becoming a carbon dioxide source. Circumpolar wildfire emissions have averaged 207 million tons of carbon per year since 2003. You compare that to about 10 gigatons of carbon that we emit every year. The Arctic remains a consistent methane source. Alaskan permafrost temperatures were the second warmest on record. You don't want to kick off any positive feedback with the thawing of permafrost, release of methane and other greenhouse gases, and then adding to the warming and the Arctic amplification and further melting or thawing of the permafrost. Warmer temperatures impact caribou movements, and survival through direct summer heat and changes in winter snow and ice conditions, with regional variations in the population declines and recoveries. Arctic migratory tundra caribou populations have declined by 65% over the last 2 to 3 decades, while the generally smaller coastal herds of the Western Arctic have seen some recovery over roughly the last decade. Previously, large inland herds are continuing a long-term decline or remain at the lowest populations noted by indigenous elders. Okay, so there could be climate refugia. As we'll see, there are some regions which are cooling, and we have discussed elsewhere how some of these species actually contribute to the cooling during the winter, because their grazing actually increases the albedo and hence allows the freezing during the winter. So they are like a Gaia, let's say. Summer heat impacts on caribou herds are projected to increase over the next 25 to 75 years, requiring shared knowledge between scientists and northern communities for management strategies. Snow accumulation during the 2023-24 winter was above average across both the Eurasian and North American Arctic. Despite above average snow accumulation, the snow season was the shortest in 26 years over portions of central and eastern Arctic Canada. Arctic snowmelt is occurring 1 to 2 weeks earlier than historical conditions throughout May and June. So spring arrives early, melting starts early, and then the September ice extent is also decreasing. We'll see multi-year ice trends and so on. Greenland ice sheet mass loss was lowest since 2013. Some good news there. Tundra greenness, a measure of expanding shrub cover due to warming temperatures, ranked second highest in the 25-year satellite record. Okay, Finally, indigenous knowledge and partnerships. Indigenous hunters are the original researchers of their homelands with observation and monitoring skills integral to their traditional practices. That's how they survive there. The Itak Heritage and Research Center in Kanjitukwapik, Clyde River, Nunavut, Canada operates the Angunsakutit program teaching traditional hunting and harvesting to new generations. These are tough words to pronounce, so apologize for that. Can I practice it? Yes, I can look up on the Google or AI and then learn them, but unfortunately I'm a bit lazy because I learn it and by the time I record it I'm going to forget it again. Okay, you look it up please. Supporting indigenous leadership in Arctic research requires sustained support of indigenous ways of life and knowledge generation. Okay, so in addition to these headlines, there is an executive summary, and then each chapter has headlines as well, as we will see. Maybe I'll need 2 podcasts to cover this report. So even though I'm being brief, it's a long report, and I want to read the most important points, especially the executive summary. Since I tend to be very brief, executive summary does give some good insights. The Arctic continues to warm faster than the global average and overall. And in 2024, for the 11th year in a row, Arctic temperature anomalies were higher than the global average again, with 2024 on track to be the world's hottest year on record. On the heel of a 2023 record, heightened Arctic warming is even more alarming. The 2024 Arctic Report Card, ARC 2024, that I'm reading brings forward direct observations of record-breaking and near record-breaking conditions that combine with stark regional differences to make local and regional experiences of environmental change highly variable for people, plants, and animals. The geographic designation of the Arctic has many definitions. I will show the map in the next slide. Each ARC 2024 essay notes the geography of focus for the observations discussed. The 2024 report provides an annual update on the 8 Arctic vital signals from ocean primary productivity and surface temperatures to tundra greenness and snow cover, and examines 3 indicator topics on Alaska ice seals, North American caribou, and Arctic lands as sources of global heat trapping carbon emissions. This report, the ARC 2024 Frostbite, contributed by Itak Heritage and Research Center in Clyde River, Nunavut, is a powerful reminder that Arctic indigenous hunters and harvesters are the region's original researchers, developing complex and nuanced knowledge frameworks that are vital for Arctic indigenous peoples and contribute to local to global research and observation. So they are just living there, but they are smart enough to also collect all sorts of data that only they can collect, and they've been doing that for a long time. So without going into detail, these are the various definitions of the Arctic. So it has high Arctic, low Arctic, and subarctic with these colors here. And 10 degrees C July isotherm, Arctic ABHDR boundary, EPPR boundary. So those are Arctic Human Development Report and emergency prevention and preparedness responses. And you have the conservation of Arctic flora and features, and Arctic monitoring and assessment program, and so on. So you just have to be aware that Arctic is not Arctic because there are many definitions. What are the headlines? Arctic-wide headlines then. We looked at a few already. Losing Arctic carbon sinks, becoming mostly sources. Wettest Arctic summer on record. Second warmest year on record. And here you have North American caribou declines. Contrasting snow seasons over here, dry versus wet conditions contrasting so close to each other, moderate Greenland ice loss, record low sea ice, Alaska extremes, and healthy ice seals over some parts of Alaska as well. A new Arctic regime that continues to change, extreme heat conditions persist, stark regional differences are seen as we saw here. Arctic hunters are key researchers and they need continued support. They had sued the US, I think, once for what they are suffering because of the warming. I don't remember what happened to it, but please look it up. These are the various regions which are discussed in the report. I won't go into the details, but there is the Arctic Ocean with the main regions, the Chukchi Sea and the Fram Strait here, Greenland Sea, Barents Sea, Kara Sea, Beaufort Sea, and Baffin Bay, and so on and so forth. Okay, Atlantic Ocean is in here and the Pacific in here, and if Arctic loses all its ice, then the summer passage may definitely be possible, maybe in the end even the winter. And it's already argued in one paper that the first day of ice-free summer may come as early as 2030, but there are uncertainties. So let's read some more of the executive summary. The multi-decadal records for many vital signs suggest that the Arctic exists now within a new regime with recent observations that are not always setting new annual records but are still consistently within a more extreme range compared to past baseline records. So we read some of these numbers. Framing the Arctic as in a new regime underscores that the region today is dramatically changed from even a decade or two ago, yet it may not imply that the Arctic climate has stabilized under human-caused warming. So we have to keep watching the trends. Okay, so we'll read headlines for each of these vital signs to get a better sense. These changes that we are seeing in a new regime together are pushing the Arctic into uncharted territory. The Arctic tundra region has shifted to being a global source of carbon dioxide. Methane is coming out regularly now. Common understandings of the timing and character of the Arctic seasons are also now challenged. For example, over the past 15 years, Arctic snowmelt has commonly occurred 1 to 2 weeks earlier in May and June, for both North America and Eurasia. Focusing on annual and long-term averages, however, can mask another key characteristic of the Arctic today: stark regional differences that can make it challenging to plan for certain weather conditions and create strongly contrasting experiences of Arctic change. It's not like entire, when we look at the warming map, it looks like the entire Arctic is warming, but when you zoom in, there are these hot spots of warming and cooling, and you have to understand what dynamics is doing that and what it means for the overall Arctic, right? So for the sea ice loss and the positive feedbacks and any potential negative feedbacks and any refugia that you may have for the caribou and the seals and so on and so forth. The Arctic works as a complex connected system. Some system connections are easier to see. For example, the Chukchi Sea west of Alaska experienced cooler than normal spring and summer air temperatures, low sea surface temperatures for August 2024, and the persistence of an unusually long-lived zone of sea ice which was formed by strong convergence and deformation in the spring. So such highly local region-specific processes have to be understood as well. So we'll read a bit more about the seals. So we do not yet know how seals' adaptive capacities are being limited or enhanced by the complex ecological changes and shifts they are experiencing. Continued monitoring and collaborations across topics, organizations, and communities are necessary. The Arctic environment of 2024 is already dramatically changed from decades past, and change will continue for decades to come. So it's in the land, ocean, air, ice, plants, animals, and so on. The ability of the caribou, for example, to adapt to climate change by moving to new regions can also be limited by roads and development, so humans are hammering the system in all ways. Herds like the Bathurst herd in the north-central Canada are under serious threat, a grave concern for local peoples whose food security has been tied to these animals since time immemorial. Arctic residents are responding in the moment to the changes underway and the deep observational skills of those like the indigenous hunters in the Kangitupap Kangitugapik region. I am massacring it, sorry about that. They are helping the communities understand, prepare, and take action. Right? So, supporting observations, collaborations, and adaptations is required in every scenario. In our connected Earth system, we all have a role to play to minimize risk, support adaptation, and foster collaboration to realize the best possible outcomes within the challenging pathway ahead. So, it's not like Arctic is so far away that we can just sit and say, let it suffer whatever it's suffering, because Arctic ice loss in the Kara Sea also affects the monsoon, creates extremes, and the pre-monsoon Arctic influence is argued to reduce the vertical shear and increase the cyclones in the Arabian Sea and so on. And there are many other examples of how Arctic is affecting the global monsoon system and many other things. Okay, so another headline to the temperature. Air temperatures at the annual scale are described in terms of water year, i.e. October 2023 to September 2024, representing 2024 as the annual average. 3-month seasons are therefore referenced as follows. Autumn 2023 goes from October to December. Winter of 23-24 goes from January to March. Spring is of course April to June, and summer is July to September 2024. These seasons span the annual cycles of the vital sign variables consistently described in the Arctic report card. So just keep that in mind, because I will just be saying again summer, autumn, winter, and so on, and annual temperatures where we are referring to the water year. Some of the labels do say water year, but just keep this in mind, and I'll remind ourselves again. Should I stop here and come back to the headlines of each chapter? Let's see. Yeah, this is a good breaking point. So we'll come back and look at headlines for each of the vital signs, and it'll be obvious which one we are looking at by the headlines themselves, and we'll look at some figures. So even though it is the report card for 2024, I'm going to focus on showing the trends over longer periods, because that gives you a sense of whether we are still just continuing the trends in air temperature, ocean temperature, phytoplankton, caribou, and seals, and sea ice extent, snow extent, and so on and so forth. Okay, so see you in the next part of this podcast.